Hi, good evening. Welcome to the Expire Show, brought to you by Science Centre Singapore, the Singapore Institute of Technology, and Neo Aeronautics. Today, we're going to explore a very interesting topic: is can Singapore be the world leading exporter of meat? Now, we all know that we are very much constrained by the land that we have, and farms. We can't have a lot of space for animals farming, but we have the vision of producing our own food, 30 by 30, 30% by 2030. So the questions of food sufficiency, or in that sense, food security, becomes very important. Can we use science? Can we use technology? And can we innovate and create meats that we can actually, not just for Singapore, for us to eat, but export to the world? So that's a dream. Well, today what we're going to do is to have a chat with Dr. Vinesh Krishnankuti on such possibility of using science to solve our food security problem. And of course, at the end, will we potentially can be a leading exporter of meat? So let's go and meet Vinesh. Hi, Dr. Vinesh.
Hello.
Great to see you. I'm going to call you Vinesh. Huh? All right. And thanks for coming.
Right.
And we are going to face a big challenge today to talk about something we never imagined, right, for Singapore. Right? Can we be the world one of the leading exporter of meat? Or, I mean, basically, if we export meat, it will be really a very big challenge, right? So based on that, let's go into the show itself, and maybe you want to talk about yourself and what you do.
Definitely. Thank you very much for this opportunity, Prof. It's a pleasure to be here. I see your YouTube interviews, so I was honored to be invited to speak. So like you mentioned, my Cellular Technologies aims to enable this to become a reality. So we are working on numerous technologies that would allow science fiction to become a reality. This is definitely going to happen. It's just a matter of time. There are a few hurdles that we need to overcome, and that's where Cellular comes in, and that's what we are trying to do.
Okay, great. So do you have any slides that you want to introduce the technology and the sciences behind it?
Definitely.
Yeah.
So I'll go through a few slides. Some slides maybe more in detail, some slides maybe reserved.
Okay.
Depending on how the conversation goes. So like I mentioned, we want to enable this culture meat revolution. And like every disruptive technology, there are things we need to, certain hurdles we need to go through. And we want to help the companies around the world overcome these hurdles. Okay, so that's
I think you have to press a little bit the other direction. Yeah.
Yeah. Okay. So it's now common knowledge that animal agriculture, the meat industry as we know it, is one of the leading causes of greenhouse gases around the world. And apart from just greenhouse gases and pollution, which I won't go into detail because you can Google that at any time. There are also other issues. Things like land erosion, deforestation, animal ethics, and also our well-being. A few years ago, it was published that due to the way the animals are kept for meat, the injection of hormones and all these things, meat itself is becoming more and more unhealthy.
I see. Okay.
So one of the benefits of this vision we have is that we can actually change this. We can actually change this at a very fundamental level. Right? So meat like this, delicious meat like this, which most people have grown to love, in the very near future will not need a slaughterhouse. And the vision is that it will come in an eco-friendly way. So like I mentioned, not just us, but there are numerous companies around the world working on this. And the way they're doing this as follows. So this is a very simplistic overview, but so to say that each step actually is very detailed. But to explain, first tissue is taken from the animal, and the cells of interest are selected and grown first in small scale, and then they're grown in a larger scale. So what we call bioreactor. Bioreactor is like a huge fermenter, and then they are packaged into meat as we know it. So some of the challenges that we need to overcome for making this a reality is that there's a difficulty in growing many critical cells that we want for meat. So I think it's easy to imagine because generally these are grown in the animal's body. Now when you want to take it out and grow it in the lab, we need to have the environment in the best possible way such that they can grow. So this is one challenge. And then as we scale up, the technologies we are using are generally coming from the pharma industry. So the pharma industry, these things are not edible, right? They're not meant to be edible. But when you want to use it for food, they have to be edible. So there's an absence of reliable edible scaffolds and microcarriers. So just to explain a bit more, these microcarriers are like tiny particles that the cells will grow onto. Tiny particles the cells grow onto, and these particles will be in a suspension. So the benefit of this is that it increases the surface area for the cells to grow.
Okay.
Right. So within a fairly large bioreactor, you can have a surface area like half a football field. So imagine that kind of space in a bioreactor that would be a fraction of the land mass. So that's the benefit of culturing in a bioreactor, and we need edible microcarriers for this because if the microcarriers are not edible, imagine having kilograms of meat. How do you remove these tiny non-edible stuff? It's going to be a challenge.
Okay.
So that's another challenge that's Honeywell is working on. And in my opinion, one of the biggest things that we need to do is to have scalable 3D meat. Because we all know that meat is a 3D thing, right?
Yeah.
And that is still a challenge. People are doing different methods of being used, from 3D printing to having scaffolds, but these are not very scalable. So we are looking at scalable way to grow 3D meat, and I'll talk a little bit more in my presentation. So we want to overcome this because this is making the cost very high, time consuming, labor intensive, and so on. So Selenium is coming in with our technologies to overcome this. So we started on a platform that allows cells to attach better and accelerate its growth. It's completely inorganic, and so it's not coming from animal products. And we have shown that depending on the cell type, we can tune the platform to have cells grow. Some cells 2 times faster, some cells at 5 times faster. And then we're also working on edible microcarriers that are from plants and vegetables. And we're also working on a 3D self-assembly system. Because if you can get meat to self-assemble, then it saves a lot of issues of scaffolding and so on. So that's what we are working on. And I'll show some data coming moving forward.
Okay.
So the first technology we are at national phase now. The second technology we just filed, third we are working on at the moment. So like I mentioned, it's completely free of animal products. It increases yield, saves time, and what is nice is that it fits very nicely into the current value chain. So people using our technology don't have to change the way they do things. So this kind of summarizes our first technology, and I'll say a few words, then I'll play a video.
Okay.
That talks about this. So basically, it's a platform, a surface where when the cells attach, they attach stronger and they accelerate their growth. As you can see the difference in the image. The one on the left is on tissue culture plastic. The one on the right is on our coating. So before we use it for meat or for whatever application, we need to get enough cells. So that's where this comes in. So let me just play a short video is it a minute long, and it summarizes this part of the technology we're working on.
Cell technologies is a big and growing field with many practical applications. Growing cells, or cell culture, is a lot like farming. You need the right conditions to get a good yield. For most cells, cell culture requires the adhesion of cells to the proper substrate before they can proliferate to larger numbers and differentiate into the cell of choice. Unfortunately, many cells don't adhere properly, produce low yield, and may even have unwanted mutations. These factors, together with the expensive cell media, drives up the cost of production. However, we have made a breakthrough in cell technology. We've developed and patented the use of a revolutionary coating that allows higher cell adhesion, lets cells grow at least 2 times faster, and unlike biological or chemical coatings, have a very long shelf life. This drastically reduces cost of production, increases cell yield, and thus profit for most applications. This method is also customizable to different cell types and is compatible with present-day solutions. Our products will be used with different types of critical cells so as to overcome many global challenges, from medicine to food. Cellivate Technologies. We invite you to join us.
So this is of the 3 I mentioned, this is the first one. And you can say maybe the most advanced. But the other 2 are also very important. We don't have a video for that yet.
Okay.
But that will come soon.
All right.
So from these technologies, the products that come from these technologies, we call them Pro site. Pro as in promoting site as in cells. Because that's really the goal. And we have products from the smaller scale, like at the point where you take cells from the animals, still structuring. So for small scale, we have cover slips, and then medium scale, we have petri dishes, and then in the large scale, we have microcarriers, both edible and non-edible, that I mentioned earlier, and then we have a 3D meat assembly, which I will talk about.
Okay.
So as you can see, this is really a biotechnology. Even though our beachhead market is the cultured meat space, it's really a biotechnology, and it's applicable in many areas. The cell-based meat industry, this is a very conservative market size of 30 billion. But the present or the latest figures are more around north of 300 million.
Okay.
Because just based on the potential and the number of people that are jumping on this. Okay, so our business model is for our companies is like this. We've already started selling some of our products, though we are at the stage of scaling up. So the initial revenue was small, but we've already started. And we're also talking to some companies and some leaders in the field to actually out-license some parts of our technology to bigger players, such that we can get some royalty, some revenue, while our platform is being used in a wider application. So these things are going on. We're also working with the largest stem cell-based company in Singapore to perhaps help them create cell-based proteins for their cosmetic applications. So these are the things we are working on this year while we scale up our production. Our vision for creating meat is to actually make personalized meats. So we believe that now we are no longer limited by the animal to get meat. So you're no longer limited by the animal, then we are not restricted to what the animal can gives us, right? And so our vision is that we won't, or rather the world won't stop with cultured meat. It will take it steps further, so we can personalize meats to individual taste, to nutrition, to health, to whatever. So all these things are possible. And we want to create, the first product we want to create would be meat where we can adjust the fat, right? More fat, less fat. And then later on we add fiber and other things. So that's like the long-term vision. So these are some of the traction we have developed over the last 1.5 years. And I won't go into details on that.
Okay.
But let me talk about how we want to move forward. So, like I mentioned, we are working on different contracts. We have initial sales, and we are scaling up and building up our team. Next year, we wanna scale up our sale, and we want to create our prototype for our personalized meats. Because otherwise, it sounds like fairy tale, right?
Yeah.
So we want to create our prototype. Actually, we already have a prototype, but this prototype we're not going to eat yet. I'll show you later. We're not going to eat yet, but the one next year we want to actually have an edible version. So our vision is really to be like the Intel Inside for cultured meat production. And also we want to be a platform for those working on cells to use. So that's the vision we have for Salivate. So this is our founding team, how we started. The team is expanded a lot more, so this is actually a little outdated, but this is really the founding team that we started with. Myself and Professor Venki, who we co-invented the initial technology, and we are the co-founders of Salivate. So Professor Venki is now in the University of Oklahoma, and we're actually working on to see how some parts of the R&D can be done there, because the University of Oklahoma is very open to these kind of innovations. And then Prof. Fan has been a great advisor for us, being in the industry itself. And Prof. Ignatius, also our advisor, who was formerly in Perkin-Elmer and Medtronics. He also advises us from different angles. So we are like every startup, we are raising money, but I won't talk in this platform. I won't talk much about it. So these are some of the organizations that have helped us. NUS gave us our first funding. We got some grants from Enterprise Singapore, and we are continuing our discussion with them. Enterprise Singapore is great because they're very enthusiastic to help local startups. A lot of the initial R&D was funded by A-Star. We got some initial funding from a boutique investment firm called Capital Code. And then we got an award from Minsui Capital last year, where they said they can help us be a partner when we go into Japan. So I'm really looking forward to that. We were nominated by the Good Food Institute, has been among the top 100 startups in Asia in this space. And we were invited to speak at McKinsey last year.
Nice.
So this kind of summarizes who we are. Now let me talk about few sentences about our vision. Right? Personalized foods is always preferred. Like I may like coffee, you may like coffee, but the way we have our coffee is probably very different. Like with milk, no milk, sugar, no sugar, right? But the fact is, people like coffee because you can personalize it to your taste. So in the same way, now that we are no longer restricted by the animal for food, why not personalize the meat itself? High fat, low fat, tougher, softer, perhaps add fiber. All these things are possible if you're no longer restricted by the animal itself. And that's the direction Salivate wants to help to enable. Right? So that's all for my presentation. Now let me show you some one or two real things that we have done.
Okay.
So this is an example. My dear friend, Professor Sriram in NUS Dentistry helped me put this together. But this is real data, right? So we use our platform, we get enough cells, and then we use edible microcarriers to grow these cells in a bioreactor, which we use. And this meat over here was produced by us, and we are already able to tweak the rigidity of the meat, right? Either compact and firm, or loose and spongy.
I see.
So that's already some kind of personalization. So in this way, we want to take it forward to personalize for nutrition, for personalize for taste, and that's what we want to do. So this is an example of that piece of meat there growing within the bioreactor. So it's completely self-assembled, like we didn't put it together, but it's the innovation itself that assembled the cell into a 3D structure again. So in our prototype next year, we hope to have an edible version of this.
Okay.
So thank you very much.
Wow, thank you. That's really a very wide and overview. Okay, so let's start from the basic first, which is actually what did you study? I mean, in your research or in your PhD.
Okay, so my undergrad was in biomedical engineering. So my PhD was also in bioengineering.
Yeah.
NUS they call it bioengineering. Um, so so after I finished my PhD, I was working on a project where we were trying to understand um, how we can quantify sensation. So we have a chip, and then we have skin cells on one side, we have nerve cells on one side,
Okay.
and we want to see if we disturb the skin cells with certain chemicals, can we measure that disturbance or that sensation on the nerve cells?
Okay.
So we're trying to quantify this.
Right.
But we were using stem cells to do this experiment. But what happened is we couldn't have the cells grow long enough because from stem cells to skin cells, stem cells to peripheral nerves took a very long time. At that time we were doing it. So the cells kept peeling off. So we couldn't keep the experiment long enough. So we're looking for options to make this better.
Okay.
We tried things in the market, we couldn't find. And so that led us to try different kinds of coatings, which led us to our first nano coating that we saw that the cells would stick better and grow faster. And so we completed that experiment, we published it. But then we realized that the coating itself is more powerful.
Okay.
So then we continued to develop, which eventually...
So it's like in all science experiments, right? When you have a certain objective and you're working on an objective and then you find that, hey, there's another thing that we can do better, like penicillin, right? Yeah. At the end of it, then you discover penicillin. Okay, great. So that's where your original research comes, and then you find there's this opportunity of getting stem cells grow fast, grow better, rather than try to stick them to certain things.
Yeah.
Okay, good. So let's talk about the commercialization or the translation part, right? So you can get the cells to cope better. What's your first business plan, or what do you think? Really, what should you do? I mean, you want to go into business, right?
Yes. Yeah. So we're already using our coating.
Yeah.
We're selling it to people who have the same problem.
Okay.
Cell growth, which is a large population, and so we have started doing work with other culture meat companies and also biotech companies who have this problem. So our coating itself is very cost effective, and we are able to solve this problem for them. So basically, that's really our first foot into commercialization.
So it's like when you digging for gold, right? Then you say, okay, I sell the
Exactly.
the chisel and all the stuff. Yeah, you sell the tools.
We are selling the tools.
Yeah. Okay.
So they call it a pick and shovel.
Correct. Yeah.
So that's all.
Yeah.
So all those that I mentioned, from the coating of surfaces, the microcarrier, they're all pick and shovel, because we are not going to make the meat for anybody, right? We're giving them the tools and say, yeah, use our tools and make your meat however fancy you want to make it.
So the interesting things is this, right? The interesting things that maybe there's also your first sales, or is based on that. Is your first sales based on that? Your first customer, is it based on that?
It's based on the coating.
Based on the coating, right? Yeah. So, well, then the coating is a business, right? So the next question is, then why you decided to say, okay, I'm going to move on beyond the coating? Isn't the coating a big business itself, or?
Yeah. So after we started off with the coating, right?
Yeah.
But then we realized that if you want to make because the vision is really to make this successful, right? Or to make the cultured meat revolution happen.
Okay.
We realize that just growing cells fast is not enough. There are other hurdles we need to overcome. And so that's how the other products started coming up.
Is it because the coating market is not as lucrative as the meat market?
No, I wouldn't say that, because there are large companies around the world that are focused on selling just dishes for coating, things like that. But when we think in terms of disruption, that is more of a additive right? We help a little bit more.
Yeah,
There are
yeah.
other coatings, we
Yeah.
are coatings, I make it a little better. But the cultured meat space is really a disruption to the whole meat industry.
Sure.
And
Sure.
so, in order to make that happen, just growing cells alone is not enough. There are other hurdles we need to overcome. And there's this quote which I heard a long time ago. I think it's by the founder of Oakley, if I'm not wrong, I may be wrong. So he says that everything can and will be made better in due course of time.
Yeah.
So from that point of view, the idea is like, why not me? So it's going to happen anyway. So since I'm already here and I know I can do it, why not do it? So I'm fortunate to have the opportunity to actually do it.
Yeah, okay, that's interesting. So you're entering a market that there's I wouldn't say very big players, but there are quite substantial players because everyone's very new, right? And so what is going to be your differentiation factor against those companies who says I have cell cultured meat and I'm already selling, but you are actually coming out with new one, right? So what's your differentiating factor?
So like you mentioned earlier, we are a pick and shovel business, so we are providing tools. So we don't see the companies that are selling meat as our competitor. In fact, we see them as someone you can work with and make them better. So that's how.
So what's the differentiating factor then?
I think
between what is being sold now and what it potentially is going to sell.
What is being sold largely is not okay. Firstly, there's only one company that's really selling.
Yeah,
right.
We all know.
And they are already selling not
patty.
It's not even patty.
Oh.
It's I don't get into trouble with this.
No, it's okay.
It's more like minced meat.
Okay, just meat. Yeah.
Like a mesh of cells with vegetable protein.
I see. So it's mixed.
It's mixed to give it its texture.
Yeah.
And really that's probably going to be there for a few years. And so people are calling it the hybrid model, where you have a mix of animal cells, animal tissue, and plants.
I see.
You see, but the thing is, it's really just cell paste. Nothing more than cell paste. But what we are talking about is actually making real 3D.
No, it's like when Chinese, right, we do meatball, and then we just put some meats, put some other things, and then put them together, right? Yeah.
That's right. That's exactly right. Yeah.
Okay. So what's the difference?
So our difference is we want to make real meat.
Real meat.
Yeah, but we want to make exactly.
I can have a stick.
Exactly.
Yeah.
Actual meat. So
Yeah.
You can have fat. You can have muscle. Grown in 3 dimensions. So a composite of different tissues, just as you get in a real meat.
Okay, that's interesting. So you have let's say we have a chicken chop. So we have the skin, and then we have the fat. Then I'm not sure what else, but we have the meat. We may have bones. Yeah. So how do you do that?
Okay. Very good question. So now imagine the chicken chop, right?
Yeah.
We would start with the fat and the muscle itself. That's where we start with.
Yeah. Okay.
One of my colleagues asked me the same question about the bone. He explained that the bone is always tastier. So is there a way we can incorporate the bone inside? So I think
you 3D print the calcium and then just stick that piece of bone in there and then grow around it.
So, I think that'll come later. Let's focus on the meat first.
But okay, Chinese maybe us like to what they call debone, so that's why.
Okay. So we're just focusing on the muscle and the fat first.
Yeah.
To have it in a composite where we can change the amount of fat, to show some kind of personalization. That's where we want to start with.
Yeah.
And then other things will come.
So you see, the interesting things is that when you eat hamburger, right, you bite in it and then it's juicy, right, which is the oil or anything comes out, right? And if you eat meatball, there's naturally no such feelings. Okay, so I'm not sure whether people want to replicate the feelings of eating a hamburger, or actually they are eating a different things?
Good, very good question. So initially, I think everybody will try to find a replication.
Because it's in the brain,
You're in
right?
the brain, correct?
The mental mindset. Yeah.
Exactly. But after that, I think this can take a leap of its own.
Mm-hmm.
Perhaps unique taste will come. I don't know. Perhaps um, health reasons. Meat has to be in a certain way. So I think after a certain time, those who want the replica of meat coming from an animal, that will be there, but there will be other varieties also. And imagine all of this coming without slaughterhousing.
Yeah.
So that's the unique part. Another thing to note is, so if it's without the slaughterhouse and without the greenhouse gases and all that, and one argument we always get is that, but there's so much energy that goes into like growing the cells and things like that. So how do how is it really better? So I think the solution to that, or the answer to that, is not in the now, because many things in the sustainability space need to happen, and together it'll be a step forward.
Yeah.
When you just change one thing, right? Just the meat itself is not enough. So it's great that there's going to be sustainable fuels. People are working on that.
Yeah.
Renewable energy, electric car. Like all of these things, I believe, should come together before we actually see a change on every front.
Yeah. Okay. I a couple of years ago, I came across a professor, my friend from Cambridge, and she said she don't eat meat anymore. And I said, why? Because is it that you don't like meat? And she said, no, not that I don't like meat, but the cow has to be slaughtered, and they have to graze on a huge plot of field, give out all the carbons, and then to grow a cow is actually a big carbon generation activity, and that's the reason why she don't eat meat, and maybe we can change her attitude on this. But I think there are firstly on the science, right, that you using stem cell, right? Is there ethical issues here?
No. You mean ethical issues?
Yeah, I'm not sure. Stem cell-based meat.
Okay. No, not really, because so stem cells is one way to go.
Yeah.
Okay. People have shown that you can even just take a biopsy from the animal itself. Right? So the animal is like a pinprick, and then you grow the cell.
Okay.
So in theory, even that is possible. So
okay.
So no, there are no, because if you're going to take the stem cells as in the traditional sense from the embryo, then again you are the ethical issues there.
Yeah.
But yeah, you don't need to take.
So I'm going to approach this through what we call the framework of pest analysis, which is the political, economic, social, and technology. I think technology are more or less cover, right? So the social side is the ethical kind of issue which you have addressed. The political side, right? So how does the government look at this type of development, right? I mean, not just Singapore government, right? But how does people react to this, right? Because when we have this GM food, right, gene therapy, gene editing on let's say crops, there's a big issue here, right? And politically, some country actually ban GM food, right? So isn't this a little bit something like that? Of course, not genes, but do you see politically there's an issue here?
Yes. So politically, I see a few issues. One is the GM argument. There are many companies who use genetically modified cell lines.
This is not genetically modified. This is
some of the cell lines are genetically modified.
Okay. Yeah.
Let's be honest. Some of them are genetically modified now, but later on, because we need to prove the concept, we need to prove the principle. So genetically modified cell lines are easier to use. But but the vision is that eventually that will change. And also having some genetic modifications allow us to use the cells for a longer time. and so on. There are many advantages. Another issue I see is that in many countries, farming is very strong. Right? The countries depend on farming.
Right.
There is a very strong heritage of farming in those countries. Australia is one of them.
Yes.
Many parts of Europe, for example.
A lot of farmings, they are government support because
Government support, yeah. Then there are farming communities. They support the government supports them. So
yes, right.
Align with them. And if you suddenly go there and say, you know what, we're going to disrupt me in 10 years or 20 years or whatever, it's not, politically, it's not going to.
Right.
So I think
so is this supposed to be treated as an alternative proteins?
So this alternate, I think we need to package it in such a way that it complements what's already there.
Yeah.
And then let evolution, take its course. Like when I started with like the gung ho mood of replacing the farm, right? But I realized that that's not practical, and you're gonna step on too many toes, and it's not the way to move forward. Rather, I think the approach would be to have a complementary system where we work together with them, and then let things evolve accordingly.
Well, surely, I think it all depends on the countries, right? Because in Singapore, if we are pushing so hard for food security, then obviously, and with no farmland, then obviously we'll push very, very hard on this, right? Yeah.
Singapore is unique in that way, but I realized that many countries that push back. For example, I was in a conference, and there was a discussion about what do you call these meats.
Yeah.
Do we call them
chicken?
Like, is it really chicken? Because there's so much of plant ingredients.
Yeah.
So is it really chicken, or do we just call it food? So I think the conclusion was like a lot of these governments are talking about hybrid foods.
Yes.
Where there's a mix of these, and also when we say hybrid foods, we don't step on the toes of the meat producers.
I see.
So politically, I think there is as we progress further, there will be more issues we have to deal with, and I believe that rather than approaching it in a confrontational way, it should be done in a complementary way, where both sides can benefit.
Okay, that's good. So we cover a lot of science and technology, right, of creation. I think the audience are looking at some business question. Okay. So maybe we'll go to the audience, right? First question, why did you choose Singapore to start this operation? Because you live here. Yeah. Maybe, but what's the investment environment and the innovation environment?
Okay, so I was postdoc at NUS, right? When we were, so I was initially in A-Star, that's where we first started this work. Then I moved to NUS to further develop it. And NUS came up with a brilliant system, which you were involved in also, where they were actually giving scientists who have the vision of entrepreneurship a chance to build something of their own. So I couldn't see myself as an academic, and I wasn't sure how to get into the entrepreneurship part, even though I was interested in it. So this came in at a very nice time when I was really thinking of what to do, and so that's why I established myself in Singapore. I mean, I am a Singaporean, right?
Yeah, okay.
I started in Singapore, and Singapore is great because the government supports it very much, right? Enterprise Singapore gives a lot of support. Apart from the university, Enterprise Singapore gives support. There are many investors coming up for early stage companies. So I think it's a great ecosystem.
Yeah, I think so because I do this show is also, that's part of my job, is to train researchers, right? PhDs, higher degree people, whether master or PhD, to use the knowledge, right? To come out with something that is of value to the economy. And not all PhDs should be a professor. I'm going to train a lot more. And I think when you go into the so-called knowledge economy, we need more people who are actually much more creative in the sense of creating new knowledge, right? And then using the IP to generate more for the economy.
Yeah.
And we need this group of people to commercialize their research findings. Okay, but the translation and especially from a scientist to an entrepreneur is actually quite difficult. All right, and because one is need to be extremely flexible. One is like very creative, but very systematic and logical. So the next question say, right, asks about, as an entrepreneur, what has been the key learning point from a business? No more research.
So as a scientist, you have the opportunity, the flexibility to do whatever interests you.
Yeah.
I can wake up one morning and I can have an idea and I can get to the lab and do it. And if it gives good result, I can seek the permission of my PI, for example.
Mhm.
So I got very nice results here. I want to put this on hold and work on that. And he'll say yes, because that's how the creatives are. Because we want to gain new knowledge, and we've discovered a lot of things like that. Where we try different things, we experiment, we collaborate. In fact, this whole platform, the oxide coating thing, started like that. It was a technology that's usually used in semiconductors and in magnetism and physics, right? We said, or rather, my co-founder, Prof. He had the idea of how would it work with biology.
Uh-huh.
Right?
Okay.
And so we're like, yeah, let's try it out, right? And that took a life of its own. But if Prof. didn't think of it in that way, he wouldn't have come.
We call the lateral thinking, right?
Yeah. So as a scientist, you have that. You have the flexibility to do that. But as a startup, the first thing we need to think is there a need? Right? If there's no need, then why would people invest money? Because people are investing money in you to come up with something, and if there's no need for the market, then there's no. So I have to change that way of thinking, right? Everything has to be, is there a need? Is there a need?
Yeah.
So that is one big difference.
Okay, very good. And let's go back to the audience question. I thought there's a question about, is it vegetarians? How would you convince vegetarian to eat this meat? So I'm not sure whether they're vegetarian because they like vegetables or because they just don't like to see cows, chicken being slaughtered. So what do you think?
Okay, so there are many different degrees of vegetarians.
Yes.
There are some vegetarians who just wouldn't eat meat.
Okay.
So this is not for them.
Yeah.
There are a large group of vegetarians who don't eat meat because of the ethical issues, the climate issues,
Religion issue.
So even religion issues, if it's related to just no meat, right? Then it's not for them.
Yeah.
But if it's because of animal cruelty and health reasons, then because there's no animal being slaughtered here.
Correct. No life being taken.
Exactly. So for them, this is fine.
Yeah.
And I know many vegans have expressed that if this comes to being, they want to try. So I think it depends on why they are being vegetarians.
Okay. All right. So the question is whether you take I think a lot of vegans is because lives are being taken. So, but the growing of the cells is not life, right?
No. In theory, each cell is alive.
Okay, each cell is alive, but there's no heart. There's no.
Yeah, exactly. But I mean, from that point of view, there's life everywhere.
Yeah.
So each cell is alive, because they are divided.
Yeah.
And all that. But it's not.
No consciousness.
Yeah. I mean, there's no. Who doesn't feel the pain?
Yeah. Correct.
I mean, you want to go into detail, but yeah.
Okay. All right. So maybe you can go to the next question. This is talking about investor, right? So what has been the top question that you have gotten from investors or consumer? Because it's a new area and is the people invest and they're not too sure. You have investors and you also have potential people who want to license a technology, means they have potential customers, right? Consumers. So what it is right now?
So initially when we first started, I think the the concern of investors is, can you really do this? It's like
Is the science good or not? So it's science fiction, which is correct, right? Yeah.
like is this really possible? But then now a lot of investors have gone over there.
Because somebody already started selling.
Yeah.
Okay.
So they've already gone over there. So now it's more of is there really a need for what you are doing?
Yeah.
So we need to show them that there is a
Yeah.
need.
Yeah.
And then another question we get is, do you have the team for it? When okay, after you have accomplished these milestones, how much do you need to go? So it's more business related questions. And being a scientist, I notice investors tend to be cautious because
Yeah.
they have the mindset that scientists cannot do business. So we need to convince them that actually doing business is to some extent easier than doing science.
Okay, interesting. So, so I think one last question. When you are managing a company, right? How one thing we're trying to encourage is for researchers to become businessmen, right? To commercialize the research. So in this translation, in this process, right? What kind of mental attitudes, right? And skill sets we can teach you, but what kind of mental attitudes you should have in order to make this transition very smooth?
Mental attitudes, huh? So I can think of it from my own perspective, my own background. One is you need to think from the person's perspective, because most in a business, we're not dealing with scientists, we're not dealing with people of a certain background. We're dealing with the world.
Okay.
So we need to put ourselves in their perspective.
I see.
See what are their needs, their interests, their concerns, their doubts. We need to understand that, and we need to speak in a language that they would understand. We have to come out of the shell that, because as a scientist, when you speak in sometimes scientific jargon and technology, the people who you are working with understand, and it becomes the norm.
Yeah.
Right, but you need to step out of that.
I see.
That is one. The other one is, like I mentioned earlier, the attitude of always asking, what is the need? Is there a market for it? Because it's easy to get trapped into interesting things, but there may not be a need for it. That's another one. The third one is to not think about yourself or about your finding or your research, but you need to think in terms of the company. The company itself is the entity. And we need to think from that point of view. And that is, all of these things I mentioned are things I'm going through at different degrees, right? And to think of the company itself as the entity, that means you yourself take a backseat, right? Because the company has to move forward. Sometimes you need to hurt people's feelings, because you need to protect the company. So it's a different mindset as being a scientist, where you're working for the university or for a research institute, but really it's yourself. It's your publications, it's your discovery. But in a company, it's very different.
So one last question, which is the question that I posed at the beginning. Do you think Singapore will be an exporter of meat? Maybe one of the leading exporter of meat in 20 years. And how can we do that?
Okay. Will Singapore be a leading exporter of meat? It depends.
We always want to be among the top 10, right?
But will Singapore be an exporter of meat? Definitely.
Okay.
Because there are many companies, for a small place like Singapore, many companies are coming here. There's a lot of investment in this space. There's investment in this space. There are companies from around the world wanting to come. I've spoken to so many companies that want to come into Singapore.
Right.
Many have already come. But there's also, but I've not come to that stage yet, but there's also a concern that as these companies expand larger, where they need to have their own manufacturing plant, Singapore may not be the right place to get that kind of large investment.
Okay.
So that is where I said, I don't know whether it'll be the leading manufacturer because they could get that in other places. But then again, we're still young, so these things will change. And the good thing about Singapore is that Singapore evolves very quickly.
But we can have a 40-story.
Yeah, exactly. And the nice thing about our government is that as soon as they see something that needs to be fixed, they do it. Things change very fast. I mean, I think this whole COVID experience is an example, right? How rules change so fast. They don't sit on something just because it's set. So based on that, why not? Why not Singapore be a leading exporter? But based on the ecosystem now, probably not a leading exporter, but definitely an exporter in the near future.
Okay, so with that positive note, we address the question is that Singapore will be a net exporter of meat in the future. All right, so very good luck and good wishes to you and in your fundraising. And so thank you very much for coming out to our show.
Thank you very much
All right.
for having me here.
So next week, speakers, we are going to have a completely different things, move away from meat, talking about manpower, recruitment, management, and will be pretty much IT driven. So we'll have Eugene, the co-founder of the Staff Annie, to join us. All right, I'll see you next week then.